All right, so let's finish up our last section already, which is 1.7, inequalities. Okay. So when it comes to inequalities, just in case you're not sure what it is, these what our inequalities are. You know, the greater than sign and less than sign rule. Now, if you're not sure what these ones, the best one is I always say Pac-Man eats the bigger number. So I always do this. So, you know, Pac-Man always eats the bigger number. So if you're wondering what in the world that is, so like for example, 5 and 10, right? Since 10 is a bigger number, you would use a symbol going like that instead of the other way around. Okay, so just in case you guys are wondering when it comes to it. So we have a form, we have the less than symbol, the greater than, less than or equal to. So this little bar on the bottom says it's equal to or less than to, so it's two different ways. And also vice versa, greater than or equal to that value as well. Okay. Which again, so for example, if I have 5 and 5 and we don't, you know, we want inequality, meaning no equal sign, you can either do this, because that means or equal to, or the other way. You could also do it that way. So both of these are actually correct because this little dash on the bottom means or equal to, right? That's the best part when it comes to it, right? So or equal to, that's the key thing when it comes to it. So just a brief introduction if you're just not sure what inequalities are as well. Now, when it comes to solving inequalities, the best part is you treat it just like an equal sign. That is the best part, with one little tweak when it comes to it, but it's not actually not a big deal anyways as well, right? So if you just treat it as equal sign, we do the exact same thing if you're just solving for it. So like, you know, solving for x, well, we would just add 4 to both sides and then divide by 3, and then we're done. So x is greater than 4. So what that means is x has to be bigger than 4 to make this true. So if I go back over here, say if I want to solve for this, x could be 5, 10, 20, but nothing smaller than 4 to make this a true statement. So when it comes to solving for inequalities, all we're trying to figure out is, okay, what is the smallest x can be, or what is the biggest x can be, depending on what situation we're actually in. Okay. Now, the only difference between an inequality and equal sign is one key difference. Whenever you are dividing or multiplying by negative, you have to switch the sign. Okay, so I'll say that again. Whenever you're multiplying or dividing by a negative number, all you do is switch the sign. Okay? For example, let's suppose right here, instead of just a 3x, we had negative 3x is greater than 12. So we would divide by negative 3 to both sides. Now we have an x here, and this gives me negative 4 on this side. But since I divided by negative, I just switch the sign. So I just flip it around. That's what I mean by that. That is the only difference between inequality when solving and an equal sign, just that extra step there. Everything else is identically the same, okay, when it comes to it. All right. So on that portion, we want to do something called interval notations. So a brief, good introduction to it. We'll get to far more detail next class and the next section as well. But this is what we want introduction to it. So we want to start writing these answers in 3 different ways. Okay. So the first way is what we did above, just writing it like that. The second way is writing in interval notation, which we're going to learn right now. And the third way is graphing it. Okay, so we're not going to graph it too much, but we're going to write interval notation far more when it comes to it. Okay, so what do I mean by the interval notation? Okay, so how do we write this? It's always going to be in a format like this. It's a comma b and parentheses. Okay, where a is the starting point and b is the end point of our portions. Okay, now if we don't have a start point or if we don't have an end point, we use the infinity symbols for each case, which means it just goes on for forever, right? There's no end point and there's no starting point itself, okay? So, for example, let's suppose we want to write this in interval notation, okay? So how this is going to work is, this says x is greater than 4, which means everything above 4 works. So our starting point, right, the a value here would be 4, and since I can go on for forever, our endpoint will end up being just the infinity symbol, looking like that. And that's it. That's all we're going to do pretty much do. So another example would be, let's say it's the opposite. Let's say x is less than 5. So therefore, when it comes to this way of writing an interval notation, it's our starting point. Remember, our always starting point is what we start with. Unfortunately, right, I can pick a lot of numbers that are smaller than 5, like 0, -5, -5 billion, and so forth. So therefore, our starting point technically it would be negative infinity in this case, because that identifies a very, very, very small negative value. And our max value would be up to 5 in this case. It's just flipped, if you notice, when it comes to it. But again, the key thing is, this number here should be smaller than that number, right? Because it always goes from start to end point when it comes to it. So any questions on these at all? Everybody comfortable? Not too complicated? Cool, I'm glad. All right. So the fun thing about inequalities is something like this. Now notice we have 2 inequalities now. Like, holy moly, what's going on here, right? Now you can kind of treat them as 2 equal signs, meaning if I just covered it up, that's the same thing we did on top, right? We would just subtract 5 and so forth and just fit it solve for x. But if I covered this side up, well, you do the same thing. You would subtract 5 and you just divide by 2, just like we did above. Which means since I'm doing it once here and doing once here, you actually going to do it 3 different ways. So for example, on this side, we would do -5 and -5. But since we have a combination of both inequalities, you would also do it on this side as well. So you do it to all 3 sides, the left, the middle, and also the right-hand side. So you're actually solving for multiple ones at the same time. So here we get -10, here we would just get 2x, and here we would just get 6. And now you do the same thing. So if I just cover this up, I would divide by 2. Well, I would do the same thing if I just cover the other side. Just divide by 2. So our final answer would be from -5x, and this is now 3, just like that. And now if you want to write this in inequality, in interval notation, well, guess what? This is our starting point, and that's our end point. So these from -5 to 3, just like that. So let's just try one more example, get you guys going. Okay. Same exact scenario we had the last one. Okay. So in this case, again, if I just cover this up, I would do -4, -4. But again, if I cover this up, I have to do all 3 times here. So again, this is -10. That goes away. And this is 8. And then divide by 3. Again, do it all 3 sides, left, middle, and right. And we get our final answer. So -10 over 3 is x, and -8 over 3. Which means our interval notation would be from -10 to 3. That's our starting point. And end point is 8 over 3 there. And voila. So any questions there at all?
Will it ever occur that the greater than and less than signs are in opposing direction? Meaning this would have said -10/3 is less than x and greater than 8 over 3?
No, they will always be pointing in one way or the other. That's the best part. So if a scenario happens, like you get stuck and they cross each other, you know something's wrong. So they always be pointing in one way or the other, which is the best part. Yeah. So we turn the page. Now let's expand on this inequality stuff. Okay. So there's one very special rule when it comes to inequalities is what happens if we have the equality on the bottom, right? That little dash, okay? Now, the best way I always remember when it comes to it is if you have the regular ones, it's always parentheses. Dash means brackets, okay? And what I mean by brackets means it's including that number, okay? So for example, let's suppose we had, again, x is now greater or equal to 4, like we had in the last example there. And again, we want to write this in focus, come on. If we want to write this in interval notation, God, this thing hates focusing. So if we want our interval notation, since we have the equality symbol, we're going to use brackets at that particular number. So again, it's greater than, so we start from 4 and we end at infinity. But since we're including 4, we put a bracket at 4 and a parenthesis at infinity. Now, here's a fun fact. The infinity symbol and the negative infinity symbol will always have parentheses because you're never technically including that number, right? It's just a symbol to illustrate that you're going on for forever, okay? So the only time you have brackets on are actual numbers like this itself, okay? Now, what that means is you can have a combination of brackets and parentheses like we did here on these examples. So, for example, let's suppose we want to solve for something like this. So notice this one doesn't have an equality, but this one does. So you know off the bat, one of these is going to have a bracket and one of these is going to have a parenthesis. But again, we just solve accordingly like we did last time. So we subtract 4 to all 3 sides. So now this gives me negative 16. This is 3x, and this is now 1. Divide all 3 sides by 3. So we get our answer, like that. So now when we write this in interval notation, we know this side, it's going to be negative 16 over 3, comma, 1/3. And since we don't have we have a regular one here, it's going to be a parenthesis here. And now since we have an equality symbol, this is going to be a bracket there. So to signify that we include the 1/3 on the right-hand side and only on the right-hand side. So any questions there? No? Everybody comfortable? Not too bad? Okay. So now that we have this part, again, that's pretty much all the concept we're going to be doing for inequalities as of now. We'll get into a little bit more graphing later on in the course, but right now it's just a quick introduction of this. And this bracket stuff we'll get into more detail, believe it or not, in chapter 2. But since we know this kind of stuff now, let's actually go to the meat of what we care about for this section. It's called rational inequalities. So in other words, fractions and inequalities, which is kind of hefty, right, when it comes to it. So this is kind of what it means by a rational inequality. We have a fraction and an inequality and then a number itself, okay? Now, telling you guys fair warning, these will get pretty lengthy at times. They're not difficult, it just gets lengthy when it comes to these type of questions, okay? So whenever you want to solve for these, right? So we want to solve this and write it in interval notation. In other words, write our answer like this at the end. It's a roughly 4 or 5 step process, okay? The first thing you want to do is set one side equal to 0, meaning we're probably going to have to bring this to the other side, right? So in other words, we're going to subtract 3 on that side, okay? The next thing we want to do is we want to combine both fractions together, which means we're going to find the LCD, like we did last section. Okay. And this time we're literally going to, or we're not, remember, we're not going to be multiplying. We're literally going to find the LCD and see what we actually need to do. Okay. And then the last, second to last step is we're going to set both the top and the bottom equal to 0 and solve each one individually. Okay. So it's a little bit more work, like I said. And then finally, which is the most important step of all, is we're going to set up a number line and we're going to mark those values on that number line and test them. Okay. Now, there's a lot of information. If you're wondering what the heck does this all mean, the best way I can think of it is just give you a simple example, and then we'll go from there. Okay. So let's just try a simple example and then follow that format. Okay. So in this case, we're going to solve. Okay. So very similar to what we have here. Okay. So let's suppose we have that. Right? So again, we're just going to take our time for this example. So step one, we want one side equals 0, meaning we have to bring this to this side. So we're just going to add 1 to both sides. Just like that. Okay. Now for step 2, we have to combine both fractions together. So if I just put this over 1, again, it goes back to last section. What is the LCD of this and this? Well, again, like I said, in most cases, it's just going to be the multiplying of both, or just x plus 2, right? So just like we did for fractions, right? So if we would add fractions together, we would multiply what's missing. So we're not going to multiply anything on this side because we already have the x plus 2. But on this side, we have to multiply top and bottom by the x plus 2, right? The least common denominator. So it's going to look like this. Okay. All right, so now add fractions together. So it's going to be all over x plus 2. So we're just going to add the tops together respectively. So 1 plus 2 is 3. And then x plus x cancels. So we just get exactly that. Okay. So now we go on to step 3. So step 3 says we're going to set both the top and the bottom equals 0 if we can. Now, what I mean by if we can is if there's no variable on top, right? We have no variable on top. We don't have to set the top equal to nothing. It's gone. Meaning we just did half the work. We only have to do one side. We just set the bottom equal to 0. Oh my goodness, I can't focus today. So we're just going to set the bottom equal to 0 because the top we can't set equal 0, right? There's no variables there. And now we just solve for x. So subtract it over. So x equals -2. So that is all steps 1 through 3. So 1, 2, 3, that's all we've done so far. Steps 1, 2, and 3. Now, step 4 is what I mean by set up a number line. So all we're going to do is make a little number line like that. Okay. And now since we only have one x, I'm going to put that right in the middle. This is -2 right there. So remember, this is a number line, right? So numbers over this, so I'll just put, here's -1, 0, -3, -4, and so forth down the line. Okay. Now, what we mean by test points. So we're going to put the marker, so we put the value on the markers there, and we're going to use test points to see if the interval is inequality true. Okay. What that means is we're going to pick the number on the right side and on the left side of -2. And we're going to plug it in to here to see, is it actually true? Is it actually less than 0? Okay. Well, so you can pick any number to the left and any number to the right. So You can pick, I'm going to pick 0 since 0 is right here. So I'm going to pick 0 because it's on that side. And then you're going to do the same thing on the other side. So I'll just pick -3. That's on this side of -2. Everybody good? Why? I picked 3, 0. Or you can pick any numbers as long as you follow that framework. So you could pick -4, -5. You could have picked 100 over here. Any number that satisfies that at all. And now all we're gonna do is plug it into here and see, is it actually true or not? And we're just gonna write true or false, depending on what we have. Okay. So let's just test it out. So if we plug in 0, right? So I just plugged in 0. Is that greater than? Is that true? Is it to make it a true statement? So, is 3/2 less than 0? True or false? False. Good.
False.
So therefore, I'm just going to put false on this side. This is false. Okay. Now we do the same thing on the other side. So I'll plug in -3, and again, see if it's true or false. So 3 or -3 plus 2 less than 0. And again, we just simplify. This is -1, -3. So is that true or false?
True.
Yep, this is true, right? -3 is less than 0, right? It's on that side, so this is true. So because it's true, that's how we're going to write our inequality, meaning only on this side does it work. So everything less than -2 works in this case. Or in other words, it goes from -infinity all the way to -2. And remember, we have a parenthesis because we started with a regular one there. We didn't have an equality down there. So this is our answer here. So any number that's between, so any number that's less than -2, -5 million, -5, anything, will make this a true statement. Okay. So any questions on our first example here? Everybody comfortable? Okay, so let's try another one. So now let's try where you have multiple ones. Let's say we have, yeah, this one. Let's say that. So actually, that one, yeah. Okay. So we're going to follow the exact same template we did before. So step 1, bring this to the other side. Okay. Step 2, we got to find our LCD. And again, it's usually just multiplying the bottoms. So just 1 minus x. So again, remember, we're adding fractions together. So we're going to multiply top and bottom by 1 minus x. So on this side, it's going to be 7/1 x minus 1 minus x. And the top is 5 times 1 minus x, all less than or equal to 0. Okay, so here we'll just distribute. Okay, and now finally, step 3, you plug everything, or we just put everything into one of them. All right, so this one you got to be very careful of, right? It's 7 minus 5. That's going to be 2. Okay. And now over here, it's going to be 0 minus a -5x. So be careful, right? Negative makes a positive. So just be careful of your minus there. So again, because you have 0 x's minus a -5x. So those canceled, make you a positive. So just be very wary of your positive symbols there. All right, so now at this point, we set both top and bottom equal to 0. So unlike this switch in here, we only have to do the bottom. This one we have to do both top and bottom individually. So we just set the top equals to 0 and also the bottom. And then we just solve for x individually. So over here, we'll have x equals 1. And on this side, we'll have x equals negative 2 over 5. So before we do step 4, any questions on steps 1 through 3 to get there? So all good? Good. So now we do step 4. Now, unlike this one, where we just had one number, now we have two numbers. So when it comes to two numbers, again, we're just going to make a line. And we're going to put them, again, on the number line. So let's say this is 1 here. Here's 0. And again, you don't have to be accurate, right? I just know that negative 2/5 is somewhere over here. I don't know exactly where, but it's somewhere, you know, to the left of 0. I just know that for sure. Right, and this is 2. And let's say, you know, this is like 3 or something, negative 3 and so forth. Okay? But now, we can do the exact same thing we did last time. We're going to pick a couple things. But unfortunately, we only had to pick 2 here. This time we have to pick 3 of them because now our number line is cut into 3 parts. The right, the middle, and also the left, the right-hand side. Okay? So we're going to pick 3 different numbers that satisfy this case here. Okay? So we're going to pick a number to the left of this value. Now, if you don't know what that value is, again, you could just plug it in the decimal. So negative 2 over 5. So it's negative 0.4. So you could pick any number that's smaller than that. So, you know, we could plug negative 1. That makes it easier for us. Negative 1 works, right? It's smaller than that number there. Okay. So a number between negative 2/5 and 1. See, this focus is nice. There you go. So we know 0 works, right? 0 is between those two numbers. And a number bigger than 1. We'll pick 2. And now we can do the same thing we did on the last one. We're going to see which is false, which is true, and which is not. Okay. So we're just going to check. Again, you could just plug it into here. So we're going to plug in negative 1, 0, and 2. And again, see if it's true, false, and then so forth. So let's find out. So this gives you 2 minus 5 over these cancel. So it gives you 1 plus 1 is there. So negative 3 over 2. So that's true, right? Negative 3 over 2 is less than 0. So this is true. Put T for true. Next up, we just plug in 0. Again, back into the same one. So 2 plus 5 times 0. 1 minus 0. So that cancels. So just get 2 over 1. So 2 is not less than 0, right? That's a false statement. So that's false. And then finally, we just plug in 2. So 2 plus 5 times 2 over 1 minus 2. So this is going to be 10 plus 2 is 12 over negative 1. That's negative 12. And that is less than 0, right? So that is true. Okay. All right, so we got our true, false portions down. Now we just have to write our interval notation. Okay. So now we have 2 truths, right? So we're going to have 2 intervals. Okay. First interval is like this side, everything on this side. So everything smaller than that works. So from negative infinity to negative 2/5. Okay, and then we had if we go back to the original, we had a equality. So equality means bracket. Okay, and then we just keep going. So we're just going to comma and keep going. So the smallest one's on 1, and this goes on for forever. So that's going to be infinity. And there we go. Same thing, bracket there. So now this time we have 2 intervals instead of just 1 as we did last time. Okay. Any questions there at all? No questions? So everybody was comfortable with that? So again, right, not difficult, it's just lengthy. A lot of these scenarios are just lengthy when it comes to it. So no questions at all? And again, this is pretty much what your homework is covering, just this scenario here. Nothing too crazy when it comes to it. Okay, you guys are quiet today. So I know we finished a little later. Again, this would probably be the latest because I did want to cover and take my time at 1.5. We probably should be finished usually around 3:30, probably the latest. But again, right, this first week is just getting comfortable. As you can see, you know, the webcam is being annoying on the focusing. So I try my best to make sure I won't do any more stuff until it kind of at least focuses a little bit, you know, when it comes to it. But other than that, do you guys have any